Welcome to a new chapter in physics, sound. In this module, we'll be discussing echo. Let us first try to understand a concept called as reflection of sound. The return of the sound wave on striking a surface back in the same medium is called as the reflection of sound. So in order to understand echo, let's go to an echo point. One of the most famous points on any hill station is generally the echo point. Well, what is so unique about this echo point? Whatever you say once gets repeated multiple times. How does this happen, you ask me? Well, we are here on the echo point of this beautiful hill station to understand the same. Now what I'm going to do is, I'm going to turn around and I'm going to shout something. What I want you guys to do is observe very carefully the sound waves, right? Here we go. Hi. Hi, hi, hi. What did you observe? What happens the moment I said hi? Sound traveled from my mouth in the distance and then it got reflected from the different mountain surfaces. And if you observed very carefully, you would have realized that this mountain is very close to me, hence sound got reflected from the surface of this mountain the first time. The second time, it got reflected from the surface of this mountain because this is the second closest. And the farthest mountain is there, that over there in the back. And sound took the maximum time to travel to that mountain and come back to me. Well, I said hi once. How many times did I hear hi? Well, I heard it 3 times. Why? Because sound got reflected 3 times from the 3 surfaces of these 3 mountains. So what exactly is an echo? Simply speaking, it's the repetition of sound after its reflection. But first and foremost, let's try to understand that the original sound is heard almost instantaneously. So I say hi, I hear hi. This is almost instantaneously. The reflected sound usually takes some time because it needs to travel, hit a surface, and then come back. How do we define echo? Well, I can define it as the sound heard after reflection from a distant obstacle after the original sound has ceased is called as an echo. But mind you, an echo cannot be heard anywhere and everywhere. For an echo to be heard, there are certain set of conditions and criteria that has to be satisfied. We are going to look at those conditions and criteria about now. Let's now try to understand the conditions for hearing an echo. One of the first conditions basically says that an echo can be heard clearly only if the distance of the person producing the sound and the rigid obstacle is long enough to allow the reflected sound to reach the person at least 0.1 second after the original sound is heard. Now, why do we have this condition of 0.1 second? Well, that has something to do with the auditory system. Now, in order to understand this, let's take a ear. Now, once we have this ear, if I were to say something, let's say if I were to say hi, what happens? If you observe that the sound waves are traveling, they enter and they agitated this eardrum over here, and the sound got transferred from the eardrum to the cochlea and ultimately to the brain. This entire process takes about 0.1 second. In fact, the persistence of sound in our ears is for about 0.1 second. Hence, what do we say? To hear the echo distinctly, it must reach the ears at least 0.1 seconds after the original sound. Let's try to understand the second condition for an echo. Now for that, let's say if I'm standing here and I have this wall in front of me. If I were to say something, let's say if I were to say physics. Now the sound goes, hits that wall and comes back to me. And let's say that the distance between me and the wall is d. Now if I want to calculate the time taken to hear the echo, it is given to me by the formula t is equals to total distance travelled upon the speed of the sound. Now understand the distance between me and the reflecting surface is d. So sound goes d distance and after reflection it comes back again d distance. So the total distance would be equal to 2d. So I can say time is equals to 2d upon v. Now understand, we already know the velocity of sound at room temperature. Let's say that is 340 meters per second. And in the first condition, we have been told that the condition for time is about 0.1 seconds. So if I were to plug in these values, I can calculate the distance as 340 into 0.1 upon 2, which gives me 17 meter. So the second condition for hearing an echo clearly basically says that the minimum distance between the observer and the reflecting surface should be 17 meter. Let's try to revise the 3 important conditions for an echo to be heard clearly. Well, the first one says that the minimum distance between the source of the sound, which in this case is the observer, me, and that wall over there is basically 17 meter. Well, the minimum distance between the source of the sound, that is the observer, and the reflector should at least be 17 meter. Secondly, we also know that the size of the reflector must be large. I mean, it should be comparable enough to the wavelength of the sound wave. And finally, the intensity of the sound should be such that the reflected sound reaching the ear is sufficiently intense to be audible. What does it mean? If I were to go to an echo point and whisper something, that sound will not go hit and come back because the intensity has gone down. So the intensity should be sufficient enough so that even after reflection, the sound is able to reach you. Well, this basically brings us to the end of this module. I'll see you all in the next module. Thank you so much.